This year, as I mentioned, we're moving forward with two new products. These are liquid handlers. The first is the FAST. This is a 96-tip positive displacement system, really pushing the envelope down to 0.1 microliter transfers. And then our Flow platform, which is an 8-channel, variable spanning, independently controlled liquid handler. Now, but we're here at SLAS, as you all know, and so one of the things we had to ask ourselves is, does the world really need another liquid handler? You look down Main Street here and you see nothing but robotics and automation. But the way we view the world is that 50 to 70% of all liquids moved in a lab are still done by a human and a person. Even in the most automated labs we've seen at some of the biggest players doing research, there's still an incredible amount of hand pipetting going on. Which is fine, because if we begin to look at what you're doing and why you're doing that, you're either doing a complex or simple lab transfer, or you're doing it frequently or daily, right? So when we create this map, there's an obvious need for these large liquid handlers that do the same thing day in, day out, large number of samples. But when we talk about the other end of the spectrum, absolutely. If you're doing just a simple plate copy or something like that, go grab your 1-channel, 8-channel, 12-channel pipetter and crank that out. But there's this huge chasm in the middle, and there's really nothing going on there. So the current state is you have somebody like this who's showing up to work on a Tuesday and going to spend 8 hours at the bench doing a protocol by hand because they had to change 1 or 2 parameters, or it's just a one-off protocol they have to do. And that's resulting in a lot of unhappy scientists who are wasting days, months, weeks moving liquids, right? So what we really tried to target with the Flow is to, still use your hand pipetters for the super simple stuff, but fill this niche, right? And so from that thesis statement, we then looked at what are our design inputs. So the current state of liquid handling is fairly complex. With these larger systems, you need to optimize every single protocol you make. They're a little bit complex to program and get started. And finally, if something goes wrong, you could be mid-process on a very complicated protocol and somehow need to recover for that, or lose precious samples or lose data. So our main goal with this system, and every aspect of it screams this, is that it has to be intelligent, it's got to be intuitive for the customer to use, and it's also got to be robust. You need to be able to recover from any error, and frankly, the machine should do that automatically and let you know what it did. So we'll get into a little bit more specifics, and I'm going to talk a little bit of features now and how we enable this. So the first thing we did is enable a vision system on our deck, because it's really annoying if you have a partially used tip box and then have to restuff pipette tips. That's probably the lowest grade of a thing a PhD level scientist wants to do. So our system will scan the deck, and you can see we put in a fairly horrible tip box, and it'll just work. It will let you know when the tip box is empty to feed a replacement to it. So you can have an incredibly long protocol and only need 1 tip box on the deck, and then occasionally have to show back up. You get a notification, put a new tip box on. The next thing we did was say, I want to put any labware on this deck and just be able to go. I don't want to have to say if it's a deep well plate, a shallow plate, V bottom plate, U bottom, anything like that. I just need to know if it's 96 or 3D4. So in order to enable that functionality, we had to design a lot of neat technology within the system. So the first thing we did was we gave our pipette channels a sense of touch. So the pipette channel, without relying on any current monitoring or anything, can sense the world around it. You can find the bottom of a well with no prior knowledge and then just begin dispensing. As well as you saw there, I'll play it again. It can do a tip touch off to make sure you have no carryover, again, without any prior knowledge of specific measurements. And you'll see it here again. So it didn't know where the edge was, but it just goes until it finds it. So intelligent from the channel design. Now, our tips themselves are very unique. You notice how we have a strip coming down the side. These are the world's first and only see-through conductive tips. So with these strips going up and down the side, not only can we do capacitive liquid level sensing, but we can also form a resistive circuit to dynamically track where the liquid of the water is. And so you'll see here, these systems are just maintaining a pressure, and by monitoring that electrical current, just following the surface of the liquid. So with those two features, you don't need any labware definition. You just need to tell it 96, 384, trough, what have you, and the system does all the rest. Now, the other thing that can be incredibly frustrating if you're an automation engineer, or complete voodoo if you're a biologist, is liquid classes and how to tune and optimize that. So, so what we've done here is, by simple fluid mechanics and pressure measurements, we, in real time, monitor the pipetting progress and adjust on the fly. So on the left-hand side here, we have a 50% PEG solution. That's pretty high viscosity solution. And on the right-hand side, we have water. So what the system does is, and these are two channels that didn't know what they were about to pipette, operating side by side. So you could feed our system a plate full of varied viscosity samples, whether you're looking at buffers, proteins, doesn't matter. They can all be independent, and our system will on the fly adjust with the sole purpose of maximizing accuracy and precision. So, and we've tested this at altitude, so if you're in Colorado, it works great. If you're in Boston, it works great, or San Diego, near the beach. We've tested all of that. But it's not enough. Because we have this amazing technology built into the system, which is really cool for anyone from an engineering background, if the system isn't easy to use, it might as well be useless. It's going to turn into a doorstop in the lab, relegated to a back closet, and we see this in labs around the world, right? So how any of our customers are going to really use the system is from the software standpoint. So again, we looked at the current state of software out there, and there's good things. I don't want to be too negative, but a lot of these things have steep learning curves where it's hard to get started. If you're coming in green and have no idea, if you've been pipetting at the bench for the past 10 years, now say, hey, use our software, it's oftentimes hard or impossible to start. And then you get into the actual protocol, where a lot of this requires a programming mentality. If, then, for loops, else, a lot of these terms that, again, if you're a biologist, you don't think that way necessarily automatically. And then a lot of this means that once you build something, in order to go back and change it, it's going to require monumental effort, right? And if you're an automation engineer, you're probably spending more than half your time supporting instruments you already have, where it'd be a lot better if you could be more efficient looking at new technologies and introducing that into the lab. So all of this turns into, if your system isn't easy to use, you kind of, you never want to use it again. So from the get-go, our software, our benchmark was that it had to be easy to learn. You walk up and use it and immediately know what you're doing. You must be able to quickly design protocols, right? In as much time as it takes you to think about your protocol, document it, and then go into the lab and do it, our system has to beat that. That's our table stakes. And then from there, it needs to be flexible. If you're doing a different protocol on a Wednesday than you are on a Tuesday, you need to be able to make that change in 2 seconds, walk into the lab, and you're good to go. So that's really where our benchmark is. And in our lab, in our booth right now, we have software that you can walk up and demo. So feel free today, tomorrow to stop by. I'll show you a quick demonstration now. So this is a simple plate copy. And so this is a quick glimpse. You can drag labware onto the deck. You can rename it, customize it from the get-go. Within our software, we have user access and management rights. So all of this is traced to who's doing it. You simply tell the software where you want to come from, where you want to go, and how much. And we try to keep everything transparent. You're not bouncing between screens. You see everything you need in front of you. and so you can't really get lost in the software either. So, and as much time as it took me to blabber on there, your plate copy is ready to go. Click run, you're in the lab, and the system does the rest. Another quick example, here we're doing like triplicate plate outs. This would be very pertinent if you're doing like a design of experiment or something like this. And again, everything in our software is very light, super flexible. While this is showing, I'll tell you a little bit more about how you use the software. It's all web-based, so you can show up to work, grab your cup of coffee, sit at your desk, program your run, enjoy your coffee, and then go into the lab and hit play. And then you have the rest of the day to do more value-added work rather than moving liquids. And so what you see here is just mapping out a couple quick transfers. It's super flexible. You can go back and forth between source and destination. All of this is traceable. There's a report at the end that's generated that you could feed into any LIMS system. And so this is pretty quick. So here I'm just plating out a simple DOE or triplicate plate and hitting go. And then the last example I'm going to show you is another simple but a little bit more complicated real-world application. So this is a qPCR plate prep. And again, we have a little bit of experience with this. But again, very quickly, this is showing a little bit of a different feature where we're going to be at least naming our stock material. So if you had a super complicated protocol with a whole host of stocks you're feeding the system, you can identify those, and you can very simply just paint your reagent onto whatever plate you want, and it's all tracked and remembered. The other thing our system does that's a very unique feature is once you create your protocol here, this is all in a virtual space. Our software algorithms then will compute the most efficient labware positioning on the deck. And it computes this against runtime. So it's going to minimize your runtime automatically. So you don't need to think about where to place your labware. The system will compute it, tell you, to really save you time. Now, if you need to stretch it to an hour, I'm sure you could put it in a different location, like if you're going to lunch and don't want it to finish too early. So this mode is our experiment designer mode, and you'll notice that it starts to give you some really neat features to show where you've put reagents, where you haven't. And if you're using tracked stocks, any mixture you create, you can rename as well. So if you're doing a multi-tiered experiment, you can, once you create a new stock, then use that in another part of the protocol. So this is our vision of how simple the world could be. We continue to innovate on the hardware and then certainly in the software, where we have a full-time software team constantly making changes to the software, and as we move forwards, we'll be continuing to add new features as well. I also want to mention briefly about the FAST platform. So this system shares all the ease of use from the software. It's a shared platform between both systems. So similarly, it's a web-based UI. You can work remotely, go into the lab. Both these platforms can serve as a common platform for an entire lab. So if you have 10 people in your lab, they could all use the same system, be programming their protocols, and then running them when the system's available. The FAST is also designed to be intelligent. Again, it's a positive displacement system, as I said earlier, so you don't need to worry about programming any liquid classes. When I say flexible 96 fixed tip head, you can either do a full 96 tip loadout, or you can go by row, by column, or by a single tip. So you could do cherry picking with the system, as well as 96 or 3 to 4 plate outs. And then finally, it's a robust system. There's a lot of sensing technology in this system as well, from encountering a known or unknown collision and acting on that, as well as error recovery if something like that happens. And both these systems have a wide array of applications and labware that they support. So with that, I'm going to conclude my talk. Again, Formulatrix, we are constantly innovating with new technologies. For the two platforms I mentioned today, the Flow and the Fast, we're currently seeking early access, early adopters. So if this is something that's like of interest to you and you realize that you may be supporting a lot of lab workers who are still doing a lot of hand pipetting, or you're constantly getting requests to like, can you tweak this protocol? No. Can you come do this? Okay, that's going to take 2 weeks. This may make your life incredibly more simple and efficient. And otherwise, stop by our booth. Again, check out all of our products. We're doing interactive demos of the software and the hardware. We're currently moving liquids in our booth, and so you can watch the systems work and come talk to us about all our offerings. Thank you very much.